Now, I've created for you a nice Big O cheat sheet. Although we've taken a lot of time to go through everything, at the end of the day, when it comes to preparing for an interview, this is pretty much all you need to know. And you can use this to review some of the topics we've covered, as well as what we're going to cover for future sections. We see here that the Big O's, they're mainly these ones over here. Now, we haven't gone through everything. We've gone through constant time, but we haven't gone through something like O log n, or on log n, or O to the 2 to the power of n, or even this one with the exclamation mark. I wonder what that is. Well, we're going to get into that. But the reason I haven't talked about them yet is because they're going to come up when we talk about data structures and algorithms. These commented out Big O notations are very specific for certain algorithms and data structures to optimize code. So we're going to get into that when we talk about these topics because they'll make more sense to you. Such as O log n is used a lot when it comes to searching algorithms. Or on log n is used a lot when it comes to sorting algorithms. And something like O2 to the power of n comes into play when we talk about recursive algorithms. So again, don't get overwhelmed. We've talked about these three major ones, and we're going to come back to the rest throughout the course. Now, when it comes to Big O's, I want you to keep in mind two things. When you're iterating through half a collection, it's still O to the power of, or O to the n. Remember, on divided by 2, it's still, at the end of the day, on. Remember our rule book. And again, another trick that often comes up in interviews is that two separate collections should be A plus B, or if they're nested, A times B. So two separate inputs should have two separate variables in Big O notation. And just to keep in mind what causes time in a function, because that's what we're measuring right now, well, operations, comparisons, looping, we know that takes a while, and things like outside function calls when you have a function inside of a function. And then finally, we talked about our rule book. Always, Big O measures the worst case. We want to remove constants. We want to have different inputs that have different variables. So O, A plus B, A and B are arrays. If they're nested, are A times B. Again, something that we've mentioned up here. The easy way to remember this is addition for steps in order and multiplication for nested steps. And then finally, rule 4 is to drop non-dominant terms. Pretty simple, right? I'm going to bring this Big O cheat sheet back when we start talking and filling our gaps with the rest of the Big O notation. But for now, let's get into the next lesson.